Hello, everybody, and welcome to the second web event of the Sustainable Powertrain Tour, a cycle of webinars organized by Powertrain magazine to dive into the opportunities offered by the latest technologies in order to achieve more sustainable power solutions.
So, a warm welcome from the editorial team of Powertrain. My name is Fabrizio Dallenogare.
My name is Fabio Butturi.
And before introducing our guests and get into the details of this web event, please let us set the stage. As you may know, our editorial platform has been recently renamed from Diesel International to Powertrain. We have decided to make this step not to exclude the diesel engine from our agenda and vocabulary, but rather to broaden our range of interests, including all the possible solutions that are likely to compete, at least in the next decade. We are talking about fossil fuels, alternative fuels, gasification, hybridization, electrification, and also hydrogen. All these technologies and all these topics will be mentioned today by our speakers. So we really want to thank them for being with us today. And I'm talking about Alexandra Tudoroiu, who is Head of Policy at Cogen Europe. Andre Banken, who is Head of International Business Development at 2G Energy International. Miguel Ruiz, Global Head of Engineering and Development at HIMOINSA. And Thomas Smith, North America Gas Segment Manager at Caterpillar Electric Power Division.
So, Fabrizio, it's a very interesting and well-balanced panel, isn't it? We can't wait to listen to them, but we thought we could start with a short video footage, an interview with Rana Adib, Executive Director of REN21. Let's leave her the floor to introduce mission and goals of the organization and provide an overall view on renewable energy sources.
REN21 is a renewable energy policy network for the 21st century, and we're a community of players from science and academia, governments, industry, and NGOs working together to crowdsource information and inform decision makers and make the shift to renewable energy happen now. And this today very clearly means like also making the shift out of fossil fuels.
So let's talk a little bit about the current situation, so the pandemic, which has led to the launch of very important plans for green economy all over the world in many countries, so the US, the EU, and so on. Mm-hmm. According to your analysis, your report, what is missing in these plans?
So basically, I think what is important to say is that 2020 could have been a key game-changer year. And why is this a case? I think there has been rising understanding and awareness of the value of clean air, low traffic, environmental consciousness, and the importance of climate change action. When we're looking at the economic recovery packages of over 30 countries, fossil fuel receives 6 times more support than renewable energy, even though all science and evidence show that we need to support renewable energy either by incentivizing it or by making it mandatory, but at the same time, we also need to stop fossil fuel. And unfortunately, I think it also translates into a really persistent and almost stable share of fossil fuel in the energy demand, which has moved from 80.3% in 2009 to 80.2% in 2019, which means like it's basically stable.
What is the role of technological development in such a scenario? Mm-hmm. And can technology really act as a boost for achieving a cleaner and more sustainable world, in your opinion?
Mm-hmm. So technology is obviously important because when we're looking into the renewable energy developments, whether it is solar PV, solar photovoltaics, or wind, or any technology, we're speaking about a technology put in place to provide electricity, renewable heat, renewable transport. When we're looking into the future, for the next 15 years, the technology that just waits to be deployed is already there. There is no need in future and new technology development. Solar PV and wind is mature, and what we need is the right regulatory and policy frameworks to make these products happen. And we even see that the finance sector, that the corporations, the private sector are very ready to engage in renewable power. And there is no time to put all the hope on technologies that do not even exist yet.
Thanks a lot. Thanks a lot. Today, we will be talking about power generation during our webinar. In your report, you mentioned the progresses made by the power sector in general compared to other sectors, maybe.
Yes, I think this is here often when you're having challenging messages out on renewable energy, and that we are not there yet. Obviously, you might almost become attackable that renewable energy cannot deliver. And I think the reality is that the renewable power sector shows that it's not a question. It's not a matter about technical feasibility. It's not even a matter about economic feasibility, because today renewable power is the least cost option. In many countries, it's even less expensive than producing electricity from coal. What can we learn from this? And I think there is really this interplay between the public sector and the private sector, which is really important. That there is a vision, that there is leadership of governments with a readiness to invest in research and development, pilot projects, create the right frameworks to support basically market development, but then also clearly phasing out fossil fuel and creating a level playing field between renewable energy power compared to fossil fuel-based power.
That was a great start indeed, and we are happy that Rana Adib was with us. Now, before involving our guests, let me remind to everyone who's watching us that you can send us some questions, because we will have a Q&A session at the end of the event. The address for sending your questions is events@vadoetorno.com. We will remind the address even later, but if you want to send questions, you can use this address. So Fabio, it's time for our first panelist. Let's get into combined heat and power with Alexandra Tudoroiu, who is head of policy at Cogen Europe, for an introductory framework. Please, Alexandra.
So I will be speaking on behalf of Cogen Europe, the European Association for the Promotion of Cogeneration. As Cogen Europe, in the past few years, we have been revising our vision to align it with our 2050 decarbonization objectives, where we see Europe becoming a resilient, decentralized, and carbon neutral economy with cogeneration as its backbone by 2050. So that said, Cogen Europe's mission is to represent the cogeneration industry in Europe by engaging with other stakeholders, engaging with EU and national policymakers, and establishing strong coalitions and partnership for the promotion of energy efficiency and cogeneration across Europe. This is a very quick snapshot of our members. As I mentioned, we represent the entire energy value chain, from cogeneration manufacturers to utilities that use CHP, as well as industrial users of CHP. In the manufacturers group, we actually represent all technologies that can use cogeneration. So that goes from gas turbines to gas engines to fuel cells to ORC systems, as well as different sizes of cogeneration from the megawatt to the kilowatt. And here you have an overview of all our members. So we are committed to achieving carbon neutrality by 2050. With that, we also say that cogeneration must be prioritized over the less efficient power-only and heat-only generation. And this is how we can achieve a lower cost decarbonization of the energy system across all sectors. As we know, there are many applications for cogeneration, from industrial cogeneration to district heating, to even building level on-site CHP. So what are the opportunities for CHP in the energy transition, and what is the larger framework for CHP? We do know that beyond power, so we know that the electricity sector is rapidly decarbonizing, and there are very cost-effective solutions to do so. However, we actually see system integration as a way forward. And first, looking at heating and cooling, this is a sector that is really hard to decarbonize. Looking at buildings and districts, they represent 40% of energy consumption, 36% of greenhouse gas emissions. There's high seasonality when it comes to providing heat in winter versus the summer. And then for industry, there's also this challenge that heating and cooling represents more than 70% of the total energy demand of industry. And those industrial users actually need high temperature heat, which again cannot be fully electrified. So from that perspective, we consider CHP a key solution to deliver decarbonization in the heating and cooling sector. Then zooming out and looking at the whole energy system, we see that the electricity production today is coupled with a lot of energy losses. So even if we're decarbonizing electricity production and there's increasing uptake of PV and wind, you can see here that more than half of the fuel input to electricity only plants is actually wasted in the transformation of energy. This shows it even better, where today in Europe we use 409 million MTOEs of fuel or energy, primary energy, to produce electricity, and 215 MTOEs are actually wasted as heat discharged into the air. So that's actually even higher than the total heating and cooling demand in buildings. So this can be, of course, fixed with cogeneration. If maybe even some of that, some of those conversion losses were to be avoided, CHP is one of the solutions that can achieve that. It avoids the waste of heat to start with. It reduces grid losses because it's distributed generation located near the point of consumption. And it also reduces the need to reinforce power grids. Then looking at the overall system and the role that CHP can play, as I mentioned before, we actually advocate for an integrated system approach. So not only looking at electricity or heat separately or even gas separately, we need to look at the entire energy system as a whole. And you can see that CHP is by its nature an energy integration solution. So it links primary energy and in some cases the gas grids with the electricity sector and with the heat sector as well. It provides flexible power to complement the electrification of end demand, as well as to complement the power supply whenever there is no sufficient wind and solar. And it does that at lowest cost possible and in the most efficient way possible. So a quick overview of CHP today. We see that the CHP sector is rapidly decarbonizing. So there's a phase out of coal that is an undeniable trend, and there's an increase in renewable fuels to combined heat and power. Today in Europe, natural gas use has been stable, and that is because, of course, we need that capacity of flexible generation into the mix, as we actually have supply increasing shares of variable renewables. So you get here an overview of the fuel mix for CHP. Also, you can see that the CHP technology is quite diverse and quite diversely distributed across Europe. Engines are a large part of the CHP fleet, and they make up quite a big share in Italy, in Spain, in the Netherlands, in Hungary, in the UK as well. And moving forward, what do we expect the role for CHP to be in 2050? We know that we are aiming for carbon neutrality, and how can CHP contribute in that respect? To quantify that contribution, Cogen Europe has actually undergone an extensive study on CHP with Artelis, one of the most recognized consultancies in system integration modeling, to actually identify what can CHP do to help Europe decarbonize towards 2050. This is an overview of the study structure. We took a system focus and a user focus, and we actually based the optimization of the CHP deployment on the European Commission's most ambitious decarbonization scenario called 1.5 tech. So that's a scenario that is compliant with lower than with not increasing temperature levels beyond 1.5 degrees. This is a quick snapshot of the results. There's much more extensive results on the website of the study. So when we optimize CHP in a net zero energy system, to provide both system efficiency as well as flexibility, we actually see that there is potential for CHP to grow and save quite a lot of money in terms of system costs. That would amount to about 40 to 8 billion euro per year net. So that takes into account the investments in the CHP technology that would be required. This is due to the energy savings that are achieved through CHP, as well as the CO2 emission reductions that are achieved for the remaining fossil fuels in the energy mix that would actually need to be otherwise abated through other means. And so at European level, we expect that CHP could meet up to 16% of the total electricity demand and a third of the total heat demand. And this is assuming that the energy system will be highly electrified. So 16% of total electricity is quite a lot already. Then diving into the more detailed results and looking at CHP users and how CHP can help users reduce their energy costs, we actually found that all CHP applications are relevant in a net zero energy system, from family homes to hospitals to district heating and to industrial applications. And you can see here the savings that can be achieved by introducing CHP as one of the solutions to supply heat to these types of users. Then in terms of providing flexibility, we have these nice charts showing how CHP can be both flexible and efficient in a net zero energy system. This focus is on heat and how CHP can be operated in a flexible way. This specifically is a district heating application where CHP would run mainly during winter at maximum loads. So it will cover higher demand and capture higher electricity prices. And then there would be heat-only boilers or even heat pumps that would be covering the remaining demand. Then when it comes to power generation and the power mix, we have here a simulation of, I think, Germany. This is Germany in 2050. And you can see that there will be quite significant differences in power demand between winter and summer. Some of this demand, the majority of this demand, will be covered by PV and wind, as you can see here. But then there will be quite high fluctuations in how much of this demand can be matched through these variable renewables. And so CHP will play a very important role in ramping up and down to meet that residual demand that cannot be covered with PV and wind. So in this picture, PV is represented in orange, and you can see that it will be quite complementary to variable renewables. So what are the sectors where CHP can play a role? As I mentioned, all sectors are relevant for CHP, and there's different reasons why, and there are different CHP applications for those sectors. So in buildings, we consider that by 2050, CHP can actually cover half of the non-electrified heat and 26% of the total heat. For industry and SMEs, of course, CHP can actually deliver higher temperature heat that is needed in industry. So its contribution can also be quite significant. And then we must not forget district heating. Today, CHP delivers above 50% of heat that is supplied through district heating. And this will remain important as well. So district heating will, we expect that it will grow, but with district heating, CHP will also increase. And what is the framework in which we see CHP playing a role? We have the EU Green Deal, which is the initiative by the current European Commission to actually make Europe the first carbon neutral continent, and do it by creating jobs and boosting economic growth. And so yesterday we actually saw quite an extensive package of legislative proposals to deliver on the EU Green Deal, and actually put Europe on an accelerated path towards carbon neutrality. The package is called Fit for 55, so this is just a flavor of the 14 proposals that were actually published yesterday. So the Fit for 55 package looks at energy, at climate ambition, at forests, as well as transport. And it revises the key legislative files that will impact CHP in the next decades. And so you can see here a snapshot of the main takeaways from yesterday's announcements. We have the Energy Efficiency Directive that was revised with higher targets for energy efficiency in terms of both primary and final energy. There is a mix there between energy efficiency and decarbonization, because we also see that energy savings obligations in the final sector, so in final users, would exclude the direct combustion of fossil fuel technologies. So this will pose some challenge to actually natural gas use in buildings and in industry. But again, these are just proposals, so we actually expect that there will be some debate on these provisions. Then quite importantly for CHP, as you may know, there is the high efficiency CHP framework, which requires CHP to be increasingly efficient in order to be eligible for funding. And this definition has just been updated to actually require CHPs that run on natural gas to emit less than 270 grams of CO2 per kilowatt hour of total energy output, which we think is a fair threshold. So most modern CHP systems that are very efficient will actually be able to comply with this condition. And also, very interestingly, the definition of efficient district heating has been amended to actually up to 2035 include CHP, but then beyond 2035 only focus on the share of renewables in district heating rather than focus on the efficiency of the fuels used. Then we have other important proposals in the Renewable Energy Directive with new definitions for fuels like green hydrogen, with quite ambitious sub-targets for renewable use in heating and cooling, in district heating and in buildings. And then beyond that, if we look at the EU ETS, the emissions trading scheme as we know it has been tightened with stricter conditions that aim at increasing emission reductions and actually increasing the price of carbon in the current ETS. And then separately from that, the European Commission would like to propose a EU-wide trading system for buildings and transport fuels. So the objective there is to actually put carbon pricing on the gas used in buildings and the fuels used in transport. So that will also, of course, impact CHP that is outside of the ETS. Then just to finalize and to conclude, so what will be the role of CHP in the energy transition? We actually think that CHP will be a key solution to deliver carbon neutrality, but also beyond that stage. We will need energy efficiency even when we've reached net zero emissions. And that is because we need to keep the cost of the energy transition down. Anything can be achieved at any cost, but consumers will not really accept that. And so what are the elements that will feed into the role of CHP? The focus on energy efficiency is, of course, important. Increasingly, the uptake of renewable energy will play a role. So on one hand, we have variable renewables like wind and solar that need to be complemented by thermal energy. But then we also need to decarbonize and increase the shares of renewable gases. So the availability and affordability of those sources will play a role. Then we also see that electrification is a key trend. Direct electrification of end use is especially promoted in the building sector, in heating, but also in transport. And there, with higher demand for electricity, there will be a need for security of supply and for backup generation that is flexible, and that's where CHP will also play a role. So that's in a nutshell what I wanted to share with you, and I'm happy to take any questions.
Okay, thank you, Alexandra, for touching so many key topics. Indeed, we believe that matter of cost saving has to be mentioned when assessing the possible benefit of solution like CHP. So before asking you a question, a flash question for the flash answer, possibly. So you have to let me say that we are running on Facebook now, so on our channel. So the question is, Alexandra, in your opinion, will internal combustion engine technology last longer, so survive in power generation more than it does in the on-highway industry, for instance?
More than it does in?
So basically, in the power generation, the usual conventional technology with thermal engine, so I mean diesel,
Yeah.
diesel one, will have a broader perspective of life compared to the other application, the cars, passenger cars, for instance,
Okay,
or
I see.
otherwise.
Yeah. I understand now. So indeed, when we looked at 2050 in the study that I've just mentioned, actually engine-based CHP was identified as a cost-effective solution in the assessment by Artelis. So some of these some of these actual use cases have used CHP in that respect. And we do think it has a future and that it plays a role, especially because of its flexibility benefits. So we see more and more projects that are using engines with district heating and are able to actually ramp up and down depending on the availability of variable renewables. So thanks to that, those benefits, we really think that engine-based CHP has an important role to play in the future.
Okay, thank you so much.
Thank you, Alexandra, once again. So talking about CHP, it's quite easy to shift from the last speaker to the first OEM we involved for this web event. We are talking about the German 2G Energy, a company which is devoted to manufacturing CHP plants powered by biogas and natural gas. And I guess we will hear also the word hydrogen in the presentation of Andre Banken, who is head of international business development at 2G. So please, Andre, the stage is yours.
Thank you very much, everyone. Good afternoon. And first of all, thanks to Alexandra for her presentation just now. So she took 80% of my policy comments already away from me, so we can just focus a little bit on the technology side. So let me quickly share my screen now. Okay, so there we are. So I trust it works. Yes, wonderful. Okay. Okay, everyone. Again, 2G Energy, those of you who might not know us, just one slide about the company, and then I switch to the technical side. 2G, as already introduced, we're a cogeneration systems and gas engine solution provider, particularly focused on biogas and natural gas applications in the past in the power range between 20 and 4,000 kilowatt of electrical capacity. So from the small scale to quite large scale applications in the industrial area. 2G is existing since 1995, so we're more or less 27 years now in this business. And in 2018, we introduced our first series of 100% hydrogen fueled gas engines in the power range right now from 115 to 750 kilowatt of electrical capacity. I'll delve into that in a few slides from now. 2G, we're stock listed in Frankfurt, Germany since 2007. The company has worldwide around about 700 employees at this stage. We were able to implement more than 6,500 Cogen systems, gas engine-based Cogen systems up till now in more than 50 countries. That includes, of course, the vast majority of Europe, the North American continent, Central America, and the Asia Pacific. Last year's turnover has been roughly 260 million euro. So by all accounts, we're not that small of a company anymore. When it comes to cogeneration technology, as I said, Alexandra already said quite a bit, so I'll keep it very brief. We already heard that cogeneration is by gas engines is by far one of the most efficient ways of energy production at the moment, because it's both sustainable and energy efficient. It not only converts the fuel, let it be natural gas or renewable natural gas, biomethane, biogas, or even hydrogen, into heat and power, but of course, coupled with the right technology, it can also provide steam or even chilled water for cooling purposes, either in district heating / cooling applications or in the industrial sector, like in the food and beverage industry, hotels, shopping malls, the chemical and pharmaceutical industry. So the sorts and types of application are quite versatile. But how do we 2G see cogeneration technology from the technical point of view? How do we see it changing, going along with the framework policy that Alexandra was introducing earlier? I mean, what we already see today is that there will be a gradual shift from natural gas, which is used today in district heating grids and so on, to hydrogen tomorrow. So this tomorrow is a not so distinct tomorrow. So because we believe it will be a gradual transition process. But the important part is that 2G has proven that existing gas engine technology, that methane-based cogeneration system, can successfully be implemented and retrofitted for hydrogen application. That means Cogen technology based on gas engine is future-proof and future-ready. So what else do we see? We see that going along with the shift in demand and the shift of power and heat production by volatile renewables such as wind and solar, we certainly see a trend that cogen systems that are implemented these days are getting larger in terms of capacity. So more capacity being installed, while the annual operating time is actually getting less. So more capacity overall, but less operating hour overall, because it's more and more gradually changing to a on-demand based operation approach, which works in combination with volatiles like wind, solar, and so on. And what we see is, and you see that on the right-hand side, is that also it's not only the engine, the hardware anymore, but also software integration that's becoming a crucial part for Cogen system implementation. Because we need these days swift reaction on market signals. So especially when we go with on-demand operating business models, so following the electricity price at the spot market, that of course goes hand in hand with the avoiding of downtimes and the implementation of AI-based predictive maintenance schemes. We call that smart maintenance, and of course self-learning machines, so that the Cogen system, the PLC itself, at some stage is able to predict when the next maintenance event is mandatory, and the unit can be operated accordingly, and that all is again irrespective of the fuel. So how does 2G see from a Cogen manufacturer point of view see the sector coupling, which again was already emphasized upon in the previous presentation? So we all agree that there will be an excess of electrical power at some stage to the increasing capacity of solar and wind, which needs to be stored on the long term. So this long-term storage for us is most definitely hydrogen. The most predominant kind right now that we see in the market is, of course, what we call green hydrogen. So hydrogen out of renewables that is produced via an electrolyzer process and then stored either locally at the vicinity or injected into the larger natural gas pipeline, existing natural gas pipeline network of, well, various countries, at least here in Europe, most predominantly Germany, the Netherlands, Belgium, the UK, but also France, Italy. There's discussion about that in many countries ongoing. That, of course, goes together not only with domestically produced hydrogen, but of course, overseas imports via LNG terminals and so on as well. So the major role and the most versatile role of the Cogen system here, and this is again why we see it is future-proof, is because the fuel we are using is not that important anymore at that stage. So we either go the direct utilization route, so use hydrogen from the local storage or from the pipeline network, so from the overall grid, and use it in the cogeneration system to provide heat and electricity on demand to the consumers, which can be, again, an industrial company, a residential living quarter, district heating, it doesn't really matter. Or we go the way, and here comes renewable natural gas or biomethane from biogas plants comes here into play, or we drive it on a combination of hydrogen and renewable natural gas in whatever blending of these two fuels. However, how do we achieve that on the engine technology? What you see here is the very basic comparison between a natural gas and a hydrogen cogen. So natural gas on the upper hand, hydrogen on the lower end. What you see here is how a natural gas cogen system with a gas engine usually works. So we have an external fuel air mixture creation. So natural gas and air as a fuel mix that's turbocharged, cooled, and then used in the engine. On hydrogen, we have the same. So we still have a hydrogen, a fuel air mixture, which is turbocharged and cooled, but we just use the airstream here, and the hydrogen is injected at the very last second, just before the combustion chamber, which is the engine cylinder, so that we have the combustion happening where we want it to happen. So we basically change from an external fuel mixture creation to an internal one. A nice side effect is that you can basically apply both technologies together. So you can inject both the hydrogen or the natural gas, so that even if you retrofit an existing natural gas cogen to hydrogen, in case hydrogen is not available in sufficient amount or at sufficient price, you still can continue to operate the system on natural gas operation or biogas for that instance as well. So it enables the coverage of peak demand based on fuel availability. Sorry, empty slide, doesn't matter. Very, very quickly, this is what is the characteristic of a cogen system running on hydrogen at the moment as a new type of fuel? Still, the major characteristics are that first and foremost, partial load operation is possible. That means you still can operate in between 50 and 100% load of nominal capacity, even if it runs on hydrogen. That means we can address flexible demands in the market for both electrical and thermal power supply. Island mode operation, that means off-grid operation or blackout start operation with hydrogen as a fuel, is possible. We spoke about gas blending already, so we can operate these hydrogen engines on a blend of natural gas or biogas with hydrogen, and we are flexible in the blend. So if we look at a transition from fossil fuel to renewable fuel, which is from methane to hydrogen, we believe it will not be with the flip of a switch, but it will be a transition process. And with this technology, we are able to address that to work on, well, increasing blends of these fuels. And last but not least, also waste hydrogen is possible to be utilized. We call waste hydrogen which is coming out of a byproduct of a chemical or industrial process, or from the metal processing industry, which is often contaminated with pollutants such as sulfur, ammonia, and so on, and is unfit for fuel cell application because it needs a very high degree of purity, but still is good to go for a cogen engine. And we see that there is a lot of unused potential for energy efficient, for sustainable and ecological friendly and energy efficient measures in that particular regard as well. I've spoke about retrofit in the beginning. This is basically how it looks like. From the top view, on the left-hand side, you see a 6-cylinder gas engine with 250 kilowatt of electrical capacity on natural gas. On the right-hand side, you see how it looks like after retrofit. So basically what we are adding is here the top part, what you see in the picture, which is a port injection system. So where, as I explained, the hydrogen as a fuel is directly injected into the cylinder, into the combustion chamber, bypassing the external gas mixing system. And this retrofit can also be done in the field. So it's can be applied already to existing infrastructure, so that massive investments when the fuel change from hydrogen to from methane to hydrogen is proceeding, there doesn't have to be massive investments in new infrastructure. And we already applied that to a couple projects. You see here some of them. So we have some of them done in Germany for public utilities. One is installed on a mega solar plant in Dubai, a project we have done together with Siemens. One is on an airport in the United Kingdom, in Scotland. And one is here in what is called a climate neutral quarter in the city of Essling, which is this one over here. Looks pretty similar to what you saw before already. This is a reference project where local solar and wind power, electrolyzers, H2 storages, and a Cogen system based on hydrogen plus heat pump even. So it's a concert of technologies is applied in this area, where in total there will be 500 residential units with 1,800 students. So it's a university quarter with office buildings and some leisure and entertainment facilities, bars, restaurants, and etc. as well. So what we believe is the transition to a hydrogen-based economy, renewable energy / hydrogen-based economy, it will be a concert of technologies, because one thing cannot do it all by itself. So it will be solar, it will be wind, it will be hydrogen, CHP, it will be storage technologies, batteries, heat pumps. It will be a combination in the end. That's the product range that we have right now that I mentioned earlier. So it starts from 115 and goes to 715 kilowatt of capacity. I'm sure the presentations will be shared later on with the participants, so I will not elaborate on that further. And last but not least, maybe for us, and I can only join in and onto what Alexandra said earlier, Cogen systems are very clear a part of renewable energy storage solutions. So how to make renewable energy storable and utilizable on demand, to re-electrify wind and solar energy. So it's a reliability of supply. It's the natural partner for PV systems. So it is sustainable as well. So we take a volatile energy producer and help making it a non-volatile one by combining it with storage and reutilization technology. So we see it as sustainable, and it's system relevant. So it can do residual load, highly efficient. So it can be part of any sort of future energy structure in concert with the vision that Cogen Europe just presented earlier. Sorry, I think I overpaced it by a few minutes. Apologies.
Okay, and no problem for 2 minutes. Thank you. So following your presentation, we heard you mention something like 2G engines can be retrofitted to hydrogen in the future. Yeah, the future is a key word. That's the point. Is it likely that the term future refers to the year 2025, just to say, or is it too early? Second question for you, so you can answer to the both questions. What kind of applications are good candidates for hydrogen retrofit?
Okay. If the future is 2025, that's a very good question. As I said in my presentation earlier, we don't think it will happen like the flip of a switch. So it will be a gradual transition. However, if we look at global trends and what we see, what is happening not only in Europe, but on a global scale with countries that are going for hydrogen economy, not as a utilizer, but as a producer. So Chile, Egypt, Australia, Saudi Arabia, Russia even. We believe that the quantity of hydrogen that is being available for utilization will massively increase in the years to come, which will naturally result in a drop on hydrogen price. But if that's already solid in 2025 is a hard thing to judge. What we believe is going to happen is that with the utilization of existing natural gas pipeline infrastructure, and just 2 weeks ago, early July, in the Netherlands, for example, the national gas grid operator, GasUnie, has received the green light to inject now hydrogen in larger amounts into their natural gas pipeline network. So we believe we will see a mix of hydrogen being part of the fuel infrastructure in the future. And we will see for the first couple years blends of fossil fuel with hydrogen, and then a gradual content switch to more and more renewable content, either by hydrogen directly or by RNG, renewable natural gas, or biomethane, becoming a mix of it. And the good thing is about the Cogen gas engine-based Cogen technology is we can accompany that gradual transition process with already existing technologies. When it comes to good applications, it would be a bit bold to say everywhere, but actually everywhere. So as long as there is a constant demand for electricity and thermal energy, there is a business case there. So it doesn't matter if it's as I said, a residential living district, if it's district heating, if it's direct utilization at a consumer like a food processing company or a chemical plant, a hotel, a shopping mall, office building. It doesn't really matter. I mean, hydrogen has to be made available. So that's either by local on-site production or via transportation, most predominantly, we assume, via pipeline infrastructure. So actually, everyone that needs power and heat, reliable, renewable, sustainable at the same time, is a good candidate for retrofit at some stage in the future, depending on how quick the transition will happen.
Thank you, Andre. Thank you. Very, very clear, really. Now let's move from an OEM to another OEM with a different focus a little bit. HIMOINSA is a primary genset manufacturer belonging to the Yanmar Group. HIMOINSA has invested a lot lately in order to reduce carbon footprint of its diesel and gas gensets. We are lucky to have Global Head of Engineering and Development, Miguel Angel Ruiz, who will tell us everything. So please, Miguel Angel.
Yeah, good morning, everyone. Good afternoon, sorry. Yeah, I hope that you can see my presentation.
We can see, yes.
Yeah, okay. So, yeah. Yeah, I'm sorry. Can you see full screen?
We can see your screen.
But full?
Not full screen, Miguel Angel.
Okay, then let me try. Is it okay right now?
Okay, perfect. We can see. Thank you.
Okay. So let me first introduce myself. My name is Miguel Angel Ruiz. I'm the Global Head of Engineering and Development of the HIMOINSA Yanmar Group. And I'm really proud of having this chance of sharing this afternoon with you all. So first thing, I would like to introduce a little bit the company. We are HIMOINSA Yanmar, a leading provider of energy solutions through our Yanmar Energy System division. Basically, solutions that are based on power generation, CHPs and GSPs, as most of you know. But I think that if you allow me, I would like to share a video that in order to have a better understanding of the company.
Energy. Energy is all around us, everywhere. It surrounds us, and whilst we cannot touch it, see it, or hear it, we can feel it. Because energy is efficiency. Energy is knowing no bounds. Energy is caring for the global environment, for our home and for our children's home. Energy moves us, transports us, and accompanies us. It is why energy is there, right beside each of our clients, in clearly differentiated and strategically structured power solutions. For generating, storing, and distributing energy. Mobile, continuous, unlimited, available 24/7. Providing reliable, quick response power in the event of unexpected grid failures. And for supplying power solutions that combine and adapt to each and every technical requirement. With a team continuously researching and developing technology to assess, identify, and develop new products. With strategically positioned engineering research centers for designing sets that are adapted to each region and application. Energy is bringing great teams together. It is why we are part of a large group, part of a pioneering enterprise in engine design and manufacture with over 100 years of experience across different industries, generating incredibly efficient and clean energy that leads us towards a sustainable future. Together, we ensure that energy can be felt in each and every corner of the planet, experiencing how it grows and grows and stands strong in its commitment to the future, in a permanent process of digitalization and automation, so that we can be more connected to the market, so that we can be closer to clients, so that we can be more efficient. We put everything into attaining excellence. Because even if we cannot touch it, energy brings us together, brings out the very best in us, and links us to the future. We are HIMOINSA, and we are here to make you feel it. HIMOINSA, a Myanmar company. Can you feel the energy?
Okay, so having a better understanding of the company, yes, I want to highlight that there are ambitious targets for 2030 and 2050 in terms of emissions. And in order to achieve that targets, we need to take advantage of all the technologies that are already available, because all of them has pros and cons. So, for example, if we focus on diesel, as a pros, is a very well-known technology, is really available, but right now because of emissions, is adding complexity and cost. If we think about the gas is also a well-known technology, and but they still have some barriers. As for example, the feasibility, the economic feasibility of the biogas, or also the local LPG regulations. If we think about batteries, they are playing a quite important role in the energy solutions today, and we expect to have a more present in the oncoming future, because mainly they will allow us to take advantage of the renewable energies, but as a cons, they are also adding complexity and cost. So, taking all that into consideration, we need a sustainable and efficient energy solution for the oncoming future. So on that regards, we have to make sure that all the technologies comes on board, that we take advantage of all the pros and we avoid all the cons. So of course, the highest level of integration you have, the highest level of sustainability and efficiency you will have. And that's the reason why we as HIMOINSA Yanmar want to have the control of main of the components of the smart grids or the microgrids. So just to finalize as a case study, I would like to share with you all a project that we have recently delivered in Istanbul. That is the Eco-CHP hospital, a 3-generation system based on 50 megas diesel and 12 megas gas, that with an efficient and complex control system, we got to produce at a high level of efficiency, electricity, heating and cooling. So just to fit to the time that they have available, that's all from my side. So if you have any questions, just happy to get.
Thank you. Yes, we have a couple of questions for you. So, for first, in many countries, governments are encouraging bioapplications by means of incentives. According to your experience, what has to be done in order to implement the global distribution of natural gas and LPG in a structural, in a stable way? And also, you can consider the AGS 30NG LPG generator as the Spanish link between today and tomorrow.
Okay, thank you for the question. HGH 1030, it's just a relevant product in our portfolio, and I think that is very much convenient for a quite number of applications. But as I have mentioned in my presentation, I think that we cannot just choose in one technology, just gas or biogas. If else we will need to take advantage of all the technologies together. And depending on the application, we will need to focus on biogas or maybe diesel or maybe a combination. Of course, the batteries will have a relevant present in the upcoming future for the energy solutions. But of course, the HGS 1030 product you mentioned will play an important role in the upcoming future.
Thank you so much for your contribution to our discussion on the matter. Now we are going to have one last very important speech and then a brief roundtable with all the speakers involved. I remind all the attendees that they can send us a question. The email box is events@vadoetorno.com. events@vadoetorno.com. So now, as you may agree, the word caterpillar goes hand in hand with the word energy. We mean that listening to Peoria's view on future development of power generation is a privilege for us. So we really want to thank Thomas Smith, who is North America Gas Segment Manager of Caterpillar Electric Power Division, for being with us today. Thank you very much, Tom, and please, the stage is yours. The microphone, Tom, we cannot hear you. Can you unmute the microphone, please?
Yes, I'm unmuting. I'm working on my screen share right here. Hopefully we'll get that going. It doesn't seem to be.
We can see your screen perfectly.
All right, let me go back to the beginning. That's a great place to start. Okay, well, great. I really appreciate the opportunity. As we talked in the sort of the pre-segment before we got on, going last sometimes is maybe not the best, but in this case, I really appreciate all the discussions that came from the previous speakers, and I think I'm going to be able to sort of wrap it up in some real-world examples of what Caterpillar is doing relative to sustainability now and into the future. Because of that, I brought one of our big yellow sustainable engines that we use in cogeneration in my green sustainable tie here. So again, my name is Tom Smith. I'm the North American Gas Segment Manager for Caterpillar Power Division. I also have the honor to be the president of the Combined Heat and Power Alliance here in North America. And it's a real pleasure to speak on renewable energy resources and how Caterpillar Electric Power is supporting this important trend now and into the future. I'm sure everybody has heard about Caterpillar, but there's probably a few things you may not know about our company. We've been in business for over 100 years. We've been supporting our customers in building and maintaining and expanding the world's infrastructure, including the Panama Canal, Hoover Dam, Golden Gate Bridge, to name a few. We're broken up into three sort of main groups: our construction group, our resources group that focuses on mining and harvesting, and our energy and transportation group, which I'm a part of. We have over 100,000 employees. We do business virtually in every country of the world, and we work through a dealer network of 161 dealers worldwide. Probably the most important function of this slide is in the lower right-hand corner. One of the things you may not think about Caterpillar, because of all the big equipment and engines and other things that we do, is we're tremendously focused on sustainability, not only in how we operate our company, but how we manufacture and service our equipment, but most importantly is building sustainable products now and into the future. Our customer needs are evolving. Sustainability and environmental awareness are now front and center for almost all of our customers. Sustainability now sits side by side profitability and growth for most of our customers. So for Caterpillar, we need to evolve with that demand and provide sustainable products to meet their goals. If you look at in the left-hand corner, you see our main focus historically in the power gen side has been on the generator sets or with our sister company, gas turbine generator sets. But we're evolving on that equipment, as was talked with 2G and others, about looking at different fuels that are sustainable now and into the future. We're also integrating our systems into solar and energy storage systems. We're packaging complete systems for our customers, whether it's cogeneration or microgrid. We're monitoring and controlling through Cat Connect, and we're supporting these on a life cycle cost. So our real focus is partnering with our customers to optimize power systems for efficiency, reliability, sustainability, and most importantly, emission reductions. If you take a look, CAT obviously provides a vast array of products, but we focus on supplying targeted solutions to meet our customers' energy needs. Just a little sidebar, I went out to a ribbon cutting for a project that we developed in Salt Lake City for a ski resort called Snowbird. The interesting part of this, and it sort of goes to this slide, is we've had a customer, Snowbird, since 1986. We installed a Cogen system there that was close to 2 megawatts. It operated for over 300,000 hours for 35 years, offering very efficient power, reducing emissions. And about a number of years ago, our Caterpillar teams and our dealer Wheeler talked to the customer about expanding that system. So now we did a ribbon cutting for what we call Cogen number 2 that produces almost 5.5 megawatts of power to meet the growing demands, utilizing the heat. And that system is so efficient that it reduces the emission of over 4 million pounds of coal-fired generation and improving the overall environment. So again, that sort of shows our commitment to the customer now and through the life of a project. If you take a look at what we're doing today, one of the previous speakers talked about the issues that are there with diesel and natural gas products relative to emissions. But for a lot of our customers in their market locations, diesel and gas generators are the most cost-effective and accessible means to get power. In these applications, we work to make our carbon-based solutions as sustainable as possible. So if you take a look at what we do on our diesel engines, for example, we not only make the engines as efficient and lowest emission as possible, we're involved in a lot of after treatments relative to oxidation catalysts, selective catalytic reduction, diesel particle filters. We're also looking at carbon sequestration. And in our gas product, which for our large engines ranges from around 200 kilowatts to almost 5 megawatts, we do the same type of things. So in today's world, we're doing everything we can to reduce carbon and making our product as sustainable as possible. If you take a look at one of the big things that we do, which is near and dear to me and obviously talked to quite a bit by the previous speakers, if you take a look at the lower left-hand corner of the slide, if you look at a gas turbine power generation facility today, that's producing around 700 kilograms of CO2 per megawatt hour. If you would get that same power produced by a very efficient cogeneration system fueled with natural gas, we could reduce that almost threefold down to 235 kilograms of CO2 per megawatt hour. So what it shows is CHP is a technology today that can truly, reduce emissions and be sustainable. It can virtually be used in any industry where you have the need for heat. It's extremely economic. Most of the projects that we're involved with have 3 to 5 year paybacks, anywhere from maybe 12 to 20% unlevered IRRs. And the big piece of that, given the changing environments that we're seeing, it also is a technology that can provide backup power. And we're seeing that in projects that we're doing for hospitals based on outages that occurred with hurricanes and other weather events. So again, a very sustainable technology that's available in the market today. One of the things that our previous speaker at 2G talked about, which Caterpillar 100% agrees with, is that we've got to look at other fuels for the future. In our diesel realm, we're working with biofuel, hydrogenated vegetable oil, and other synthetic fuels to reduce emissions. In the natural gas side, we're working on biogas, landfill gas, any type of gas that is available that we can run our engines on. We're focusing on that. And as our speaker at 2G mentioned, as the hydrogen economy develops, we're going to be right front and center to support that. We have over 20 years of experience on running our products, both gas engines and turbines, on hydrogen. We're working currently and running our systems on hydrogen blends, and we're doing an amazing amount of ongoing research. So we're going to have the products available when, as our previous speaker mentioned, the hydrogen economy is here. A little bit about what we're doing in the biofuel side. Biodiesel, we have been involved with for well over a decade. Many of you have probably seen, we did a press release with Microsoft where we're actually working on a renewable biofuel for data centers that they have in Sweden. So again, this renewable fuels are here right now, and obviously they're going to be here and going strong into the future. A little bit about what we're doing currently on biogas and biomethane. As most of you know, methane is the second most harmful greenhouse gas next to CO2. Projections say that this market will double in size by 2027 and have an annual growth on top of that of anywhere from 5 to 10%. So again, this renewable gases are tremendously important for power gen and for the global power generation economy. 20% of our gensets currently go into biogas and biomethane. We have in the last 25 years, we've provided over 5,000 gensets that operate on these fuels. and are generating over 5,000 megawatts of power. So again, a very, very important factor for the industry. Just going through a couple examples of this. Obviously, there are numerous ones we can choose from. I just took a few. One of the more interesting ones is we have a project in Idaho that generates 4 megawatts of electric power. The waste heat, again, it's in a cogen mode, is recovered to run the anaerobic digester. Believe it or not, it utilizes 200,000 gallons of manure that's processed daily as a fuel. And this prevents over 40,000 tons of methane being released into the environment every year. So again, it's showing how we're focused on emission reduction and sustainability today. Another very, very large project is a 16 megawatt wastewater treatment facility that's located in Dubai. This project produces 16 megawatts of electric power, uses all the waste heat that's produced off of the engines. And again, it's a very important contributor to the power requirements of the wastewater treatment facility, as well as reducing emissions by using waste fuel. The last example that I have sort of in the biogas side is another agricultural project where we're generating 1 megawatt of electric power, and again, using the waste heat to run a digester. So again, it shows what Caterpillar and our customers are doing today to lower emissions. A little bit about hydrogen. As I mentioned before, we have over 20 years of experience in running our products on hydrogen. We're very active with the US Department of Energy on hydrogen-based programs. We have a hydrogen system that we're actually running on a fuel cell that's going to be a 1.5 megawatt system. We have a 2 megawatt system that we're running in combined heat and power on hydrogen that's actually going to be at a district heating system. So again, very, very focused and being on top of alternate fuels as they become available into the marketplace. A little bit about Caterpillar and the range of our products. As you can see in the group that I work with, which is called our LEPs, or large energy or large electric power systems. We have products that range from 200 kW all the way up to around 5 megawatts. These products can run on natural gas, landfill gas, biogas, coal gas, wellhead gas, hydrogen, now and into the future. So it is a very, very broad product line. It's been around for a while and updated, and it's going to be around in the future, as you asked one of the previous people talking about reciprocating engines. One of the things that CAT's doing to make sure we're current now and into the future is we're very focused on microgrids and renewable energy. You can see we have renewables, energy storage, gensets, controls, all integrated together into a complete system. The microgrids example that our microgrids that we have, range anywhere in size from as small as 10 kW to as large as 100 megawatts. We offer complete microgrid solutions that are supported by CAT and our dealers. We can do turnkey or design to order. Being that we're a very large global company, we can support financing, warranty, and service agreements, all things that are very important to the advancement of microgrids and lower emissions. Sort of a reference site of this is in the United Arab Emirates. It's a 5.94 megawatt hybrid energy solution at a climate controlled greenhouse. You can see that we're running that with some diesel engines, 2.7 megawatts of solar, 370 kW of energy storage. We have a microgrid controller, and it's monitored and run through our CAT Connect program. The great thing about this project is it saves over 1.4 million liters of diesel fuel a year, which was historically the fuel that they use, to run this facility. If you take a look at where we see the future going, our commitment is to sustainability. Again, not for how we run our company, how we produce our products and the products we make for the market. You know, I share the passion that everybody has about driving towards net zero. And I think that, as our previous speaker said, and I would totally agree with, there's not just one solution. It has to be a mix of all solutions, and it has to have everybody working together to meet this goal. Thank you.
Okay, thank you, Tom. Sincerely. So, focusing on Cat's way to the smart grid. Caterpillar is able to provide more than just engines, basically a global solution provider. Can you tell us about the flexibility of your system to accomplish different legislation around the world? That is very complex matter, very complicated matters.
Yeah, that's a great sort of summary from the presentation that I did. Obviously, you know, we've been in the power generation business for a long, long time, and will be into the future. It's a core piece of our business. So meeting with current trends of sustainability and lower emissions, you know, we do that through our existing products, of whether it's engines or gas turbines, and how we utilize those in different technologies like combined heat and power. The other thing that you wouldn't think of a company like Caterpillar being an engine and heavy equipment manufacturer, we're diversifying into other markets. And I talked about that relative to microgrids and renewable energy. Had just announced a venture with a company that's transporting renewable fuels that can be used in our products and other products. So we're not standing still. We understand the focus towards sustainability and zero emissions, and we're doing everything we can as a company to get there.
Thank you very much, Tom. Indeed, I think we've had some very interesting presentations so far, and points of view above all, because we are looking for different point of view to understand the changes that are going to happen in the near future. I just want to remind you that from tomorrow you will find the presentations you've seen today on our website, dieselinternational.com, and we will also publish the video of the event on our website and on our YouTube account. So from tomorrow you will have everything on our website and accounts. We are very close to the end, so I think it's time to sum up and look at the future. So we would like to make a question, one last question to our panelists. Let's talk a little bit more about cogeneration. So I'm referring to Alexandra, maybe Andre. What role will cogeneration play in the coming decade if it is not subsidized by the government? So in other words, how much government incentives can trigger the role of CHP in the near future? So I mean in the following years. Let's start from Alexandra, maybe.
Very good question indeed. So we see that our climate and energy objectives are increasingly focused on energy efficiency first. We've seen the IEA setting that precedent by calling energy efficiency the first fuel that must be used. And many actually think that CHP is a technology that is mainstream technology. So why would it need to be subsidized? And indeed, it pays off to have cogeneration. Your energy costs will go down. You are contributing towards system efficiency and flexibility. However, that upfront cost, which is higher than just installing a boiler, prevents some of the users from actually going for cogeneration. And this is where policy and support schemes come into play. So what policy can do is to remove barriers for CHP. Simple things like grid connection. So a simplified grid connection or a less costly grid connection for CHP systems will tremendously help an industrial user, for instance. And then yeah, so and other ways of incentivizing CHP is to really monetize those system benefits. So I'm thinking here of grid losses that are avoided through CHP. This could actually be returned to the user in the form of some sort of incentive like feed-in tariffs, feed-in premiums, and so on. So I think there needs to be a mix of removing barriers, and then when there's still a gap in cost competitiveness compared to less efficient solutions, then indeed there's a role for subsidies as well.
Yeah, and maybe I can add to that a little bit, and I agree 100% with what Alexandra said. In my role as president of the Combined Heat and Power Alliance here in the US, I do a lot of discussions with different people about that exact question. And CHP in and of itself does make a lot of economic sense. As I showed in my presentation, we have very quick paybacks. To Alexandra's point, a lot of times we have a lot of barriers that are set up, whether it's electric interconnects, standby power tariffs, things that make it a little more difficult for CHP to work, even though in my humble opinion, they probably shouldn't be there. So some of the subsidies and support that we get from tax incentives or state incentives here in the United States really help to knock those barriers down. And we're also working, here in the US to develop incentives through tax incentives on a federal level that would incentivize people to use, let's say, lower carbon fuels. So if you have a current CHP system, you may have a 10% subsidy if it's on natural gas, or tax incentive if it gets to using alternate fuels, let's say the biofuels or hydrogen that are approaching, some others, you'll see that tax incentive going up. So I think the role of incentives is really to drive what industry is doing and to knock down some of those barriers. So I do think that incentives should be there for CHP. And if we're treated equally to, let's say, some of our counterparts in renewables, you'd see a lot more deployment. Globally, CHP represents about 15% of the power in the world, only 8% here in the US. So, there's a lot of room for expansion.
Thank you, Tom. Andre or Miguel Angel, if you want to add something, you can tell us.
Well, I guess Alexandra and Thomas said most of it already. There's not much to add from our end. We see it quite similar. I mean, not too much on the European, but on a global level, we see that there are sometimes hurdles still for cogeneration implementation. Alexandra mentioned grid connection already. Thomas mentioned tax subsidies on the type of fuel that is being used. I talked a lot about content or fuel switch. So that's all more or less aligning with one another. So I would say from a technology point of view, the greatest hurdle is, well, grid connection and fuel taxation on one thing. The other thing is we see sometimes that there's still sometimes reservations about, well, not in Europe, but in other markets, reservations about cogeneration technology, how it implements, how it impacts on it, especially if installed on existing facilities. So if it goes into existing infrastructure, and we all know that it actually contributes to the reliability of existing energy infrastructure, dynamic grid support, load support, upkeeping frequency levels. So that's maybe a point, not necessarily in hard financial numbers, but that should be considered in policy making, that there is this contributing factor on overall energy reliability by cogeneration application as well.
Okay, thank you very much. As we promised at the beginning of our webinar, we picked a question coming from the audience. It's a very, very, very peculiar one. So anyone who wants to provide an answer, just provide the answer to this peculiar question. So the question is coming from India and says, can we use humans' waste to create biomethane, for example? Can this trigger the creation of biomethane in the future?
Yeah, maybe I'll take a stab at that great one. Having spent a lot of time in India, I know there's a lot of people, as there are in a lot of areas of the world. If you look at, like the example that we had in the wastewater treatment facility, that basically is what we're doing, is using the waste that comes in the wastewater to produce power. So it's currently being done, and it is something that's becoming more and more prevalent. Obviously, Caterpillar and other manufacturers are supporting that. So the answer is yes.
Okay. Finally, I think that's all. Okay. Thank you to all the panelists. It's not simple to find such experienced experts who are at the top of the industry, the various different stages of the power generation process. So I'd like to remind you the third and last stage of Sustainable Powertrain Tour 2021 in autumn will deal off-highway application. So stay tuned on our channels for all the details. Okay, take care. We are both vaccinated. We guess all of you are the same. So stay fine, take care, and enjoy your summer. COVID-free, hopefully.
Yes, thank you to all the panelists who joined us today. It was very, very interesting discussion. Goodbye.